morning, students. Today we are going to do the recap what is covered in the last two lecture of Unit 4, especially on the stress upon case studies on applying advanced data analytics techniques to real-world chemical engineering problems. So these are the learning outcomes we have studied. I will quickly go through the 5 case studies which predominantly we are talking about in the few lectures, the last lectures. Okay, the first one is a process optimization in a distillation column. The objective is to find the separation efficiency at the distillate, and the data used are temperature, pressure, composition profile. The technique is principal component analysis, is a dimensionality reduction technique, and the k-mean clustering is an unsupervised learning technique which has been adapted, as a machine learning models, to find the process optimization in a distillation column. So the outcome is the identification of hidden operating modes and process fault. Coming to the second case study, which we extensively discussed, in the previous lecture, regarding the predictive maintenance in heat exchangers. So the objective is to prevent the fouling and improve the uptime. So when you try to prevent the fouling or just try to extend the deadline, extend the fouling repair maintenance time, obviously that will help you to have a low maintenance cost. Otherwise, the frequent shutdown or frequent maintenance will incur the cost for the process. And the data used is the temperature difference, flow rate, and time series data. So you know already the heat exchanger, the parameters which need to be mainly concentrated is inner diameter, the design, inner diameter and outer diameter. Okay, in the process side, we'll see the inlet cold fluid, outlet cold fluid, inlet cold hot in and inlet cold out. What is the pressure drop inside the tube side, inside the shell side? Okay, so what is the heat transfer area, overall heat transfer coefficient? These are the parameters which we have been testing, right? The data used actually mainly here in heat exchanger is time series data, temperature difference, and flow rate. The technique which has been adapted over in this particular process, chemical process heat exchanger. Okay, so the random forest and long short-term memory network is a recurrent neural network which has been used for the switch recognition as well as the tone pitch. The outcome of this thing is a yearly direction of fouling, optimized maintenance, and schedule. Coming to the three, thirds, and fourth and five, I didn't explain elaborately during my lecture, but however, I will concentrate on this. So, what is the advantage of using this type of techniques for this process? Okay, obviously, so what are the things which need to be considered while doing this wastewater treatment process modeling? Okay, so the objective is whatever the process, we need to consider this fourth thing. One is objective, what is the data used, and what is the algorithm, machine learning algorithm which you are going to use as a technique. Okay, and what is the outcome? So for any process, whether it may be any unit operation or any unit process in a chemical plant, this need to be considered. So by which we could able to see the application of machine learning data analytics, advanced data analytics in chemical process. Okay, so then we need to go one by one and need to elaborate it, need to study. For example, they predict the effluent quality. How to find the effluent quality based on the unit operations like a aeration tank. Okay, what is the clarifier efficiency, pressure sand filter, flow sand filter, rapid sand filter, the carbon filter. So what are the efficiency of removing the effluent? Okay, so each unit operation will have its different objective. Okay, to treat the particular effluent. So obviously, when the inlet of the effluent get enter into a wastewater treatment plant, has to be reduced to the standard, whether it may be set by US EPA, United States Environmental Protection Agency, or else Central Pollution Control Board of India or State Pollution Control Board of India. Okay, so the particular state of India. Okay, so we need to find the predict the effluent quality. That is the objective. Whether it's within the standard or not. If not standard, obviously we need to enhance the process, or we need to find it out where it went wrong. So why it has not been treated up to the standard, or else what are the unit operation which need to be added in order to bring the effluent level to a particular standard set by the regulatory agencies. Okay, so coming to the data used, the influent characteristics, process parameters. So that is the data which need to be taken care. The process parameters, for example, how much is the air air parameter which need to be given. Coming to the artificial neural network is a supervised learning. So there will be a correlation between the independent variable and the dependent variable. Is a explain we could able to this type of model will help you to give you a justification. Okay, for any authorities, okay, or regulatory bodies, whether it's a USCPA or a state pollution control board or central pollution control board. Okay, how the algorithm need to be written. So what is the outcome of this using this algorithm? Better control strategy. So it will optimize the point. Actually, what is the process condition that need to be maintained so that the effluent characteristics come within the standard. Okay, so that is the idea of about it. Okay, better control strategy, reduce the chemical consumption. So let's say I will say you advanced oxidation process. The advanced oxidation process in a wastewater treatment, okay, by adding the ferrous sulfate and hydrogen peroxide. So the main objective of to treat the compound with advanced oxidation process is that the compound which is not easily degradable, recalcitrant in nature, that can be degraded by adding the ferrous sulfate and hydrogen peroxide. Because when you add this compound, it will form a hydroxyl radical. This hydroxyl radical have the potential to degrade the compound which are highly organic, I mean isorganic in nature, I mean external structure in nature. It will go for a, it will help you to get a mineralization, that is carbon dioxide and water. So meaning to say, when you add this compound, how much is my dosage which need to be added for the influent? Okay, so this control can be carried out, okay, by this using this algorithm. So the reduced chemical consumption. So the effluent characteristics outside is already is less than, very less than the disabled standard, is well and good. But at the same time, we need not necessarily need to add more and more chemical. So we can optimize the chemical consumption, okay, by seeing the things how we need to manage. So by adding the ferrous sulfate and the hydrogen peroxide, there is one disadvantage on the other side is iron precipitate will be formed. Okay, and the total suspended solid will be increased in the process. How you manage that one? So we need to know the domain knowledge, and also we need to know actually what need to be carried out, what should be the outcome. Okay, how these parameters is corrected. This, if you know, obviously that will help you to get a using the machine learning model to control this strategy. So this is the idea. So it's like a model predictive control. So the model predictive control, you have a positive variation or negative variation. Accordingly, the data need to be carried out, and then so that it will be adjusted to get a optimized point. Coming to the fourth point, case study, that is a fault detection in a reactor system. So as I told you while covering this part, okay, I just give an example for reactor. Okay, so let's say you have a reactor, the time series analysis, the time series data has been collected. So with respect to every second or 5 minutes, just collect the data of how much is the reactant concentration, what is the temperature, what is the pressure inside the reactor, and so on and so forth. So the rapid detection of abnormal operation is the objective. So abnormal operation, let's say if there is any variation in the process condition, because let's say you have a reactor, okay, and this reactor is giving a what you call abnormal process condition. Okay, so obviously that will leads to one is a safety aspect, another one is a what you call the output will not be consistent or output is varying. Okay, that means the product efficiency is not good. Okay, so the data used is a multivariate sensor readings. So they will try to take the readings from different parts of the reactor. Okay, either by means of the using a sensor, okay, or else by flow meters and things like that. Okay, so when you see here, for a batch reactor, there won't be any flow meter because it's a batch process. Okay, but obviously they will try to measure by using a sensor the temperature and pressure, and the reactant concentration. Okay, also can be carried out by means of sensor as well. Okay, so when you see the technique, support vector machine is a supervised learning, and the principal component analysis is reduction, dimensionality reduction technique. Okay, so the outcome is the improved safety with a quicker alarm triggers when there is a fault detection, when there is any deviation from the normal point. So that will help you to identify immediately, so that the safety aspect as well as the process product efficiency will be maintained. Okay, so this is a case study 3, and coming to the case study 4, fault, sorry, this is a 4, and coming to the case study 5 is a real-time energy management in a chemical plant. So the objective is optimize the energy usage. So the energy usage is very important for any process. So effectively if we use it, the cost will be less, otherwise the energy will increase the cost. So the outcome is 10 to 15% reduction in the energy cost. So the technique algorithm they used either the regression analysis or the reinforcement learning. So the real data used actually the real-time energy meters. So for example, if it is weather data and production data, so this depend on the process. Okay, so these are the 5 case studies which we have seen, and the coming to the process optimization in distillation column, we have discussed very elaborately during the few lectures. So try to understand this one key findings. So when you try to optimize the process by using the algorithm like principal component analysis for distillation column, okay, the operation in model B lead to 6% lower energy consumption. So what is the mode actually? Just see the mode. Mode A is high separation, high energy. Mode B is moderate separation, energy efficient. Mode C is suboptimal operation or frequent disturbances. When you see here, the operating in model B lead to a 6% lower energy consumption with minimal purity loss. Okay, so the model B lead to a 6% lower energy consumption. So as the energy consumption is low, obviously what the cost will be less. So we need to operating in a model B with the minimal purity loss. Okay, so feed temperature and reflux ratio were the most influential parameters. So the features data. So this I mean very important parameters that need to be considered. Out of which, even though we are collecting the data, okay, by time series analysis, but what are the main parameters which has been influencing the output? Okay, so where here the efficiency of the distillate, I mean the purification, the separation efficiency. Okay, we need to say the separation efficiency of the distillate is the main parameter that need to be considered. So the feed temperature and reflux ratio play a predominant role. Okay, in the purity, where the most influential were found to be the most influential parameters. Operators were often unknowingly switching between the modes due to minor set point changes. So if there is a minor set point changes, obviously this will be moving. So obviously you should be very precise. Otherwise, what will happen? It will go to the mode A or mode C, which is not efficient mode. Okay, so we should be very careful. Okay, operators are often unknowingly switching between the modes due to minor set point changes. That is very important. Okay, so when you see the recommendation for the distillation column, implement a soft sensor dashboard using principal component analysis code to visualize the real-time mode. So we have elaborately have seen what is principal component analysis course. Okay, develop a decision support system to recommend the optimal reflex ratio and pressure settings. Okay, schedule operator training to maintain the steady operation in mode. So in mode B, operating training. Schedule the operator training to maintain the steady state. How to operate maintain the steady state? That means to, so that will leads to a mode B option. Okay. Schedule operator training to maintain the steady state operation. So here the steady state operation is mode B. So otherwise, if the operator not properly maintain the things set points, obviously what will happen, that will go to the mode A or mode B. So the recommendation, schedule operator training, okay, operator training to maintain the steady state operation in mode B. And what are the impacts and benefits? So the energy saving is 5 to 10%, improved productivity. So what is the advantage of using the data analytics, advanced data analytics in chemical process? So that will help you to save about the 5 to 10% reduction in energy. Okay, so energy saving is almost 5 to 10%. Reduction in steam usage, improve product purity consistency across batches, reduction in manual trial and error operation. So otherwise, what we need to do, we need to keep on doing the trial and error method to find the very optimized point. Okay, that is a time consuming process. Okay, enhance the understanding of multivariate interaction in the column behavior. So this will help you to find it what are the features which are after dimensionality reaction, what are the factors which need to be considered, especially for the output. Okay, so what are which factors which is more predominant? Okay, and coming to the learning outcomes of this particular distillation column, understand how unsupervised learning like principal component analysis and clustering can reveal the hidden patterns. Appreciate the importance of data driven decision in optimizing the traditional unit operations. Recognize how historical data, when mined properly, can offer the actionable process improvements. Okay, so then we'll go for the second case study, the predictive maintenance and heat exchanger, that we already have covered extensively. So I quickly go through it. These are the data need to be considered, but out of which we have a feature engineering, okay, random forest regression, Random forest regression is a supervised learning, built a predictive model to estimate the fouling resistance based on the historical variables. Future importance revealed the pressure drop, input temperature, and flow rate were key contributions. So when you see this long short-term memory, this has been used as a what you call the speech recognition as well as the tone pitch. Okay, so the applied LSTM is a type of recurrent neural network for time series forecasting. Okay, trained to predict the future fouling in resistance based on the past historical data or past behavior. Okay, the forecast 7 days in advance with 80% 85% accuracy is the advantage of going for a long short-term memory neural networks. So this type of models which has been used okay, in order to predictive maintenance. Okay, key findings 7 to 10 days before we can find it out these fouling before it occurs, and the random forest provided a good interpretability, but it's a long short-term memory outperformed in forecasting accuracy. Okay, so even though it give a good interpretability, but outperformed. Okay, the LSTM will give a outperform, that is better when compared to the random forest. Maintenance logs showed a mismatch between the actual founding and the cleaning frequency. So by using this technique, we can find maintain the logs showed a mismatch between the actual fouling and the cleaning frequency. So the recommendation goes like this: using the short-term memory, long short-term memory model in a real-time dashboard to monitor the predicted fouling values, trigger cleaning only when predicted fouling threshold exceeds the critical value, update the model continuously using new process data, online learning. So, okay, so what is the advantage of before and after analytics? So cleaning frequency 20 days is required before analytics, now is 32 days. So that means we are postponing so that the time period has been extended, but despite we could be able to do it for the the fouling before fouling occurs 7 days before we could be able to predict. That is the advantage. Okay, unscheduled downtime. So before, even though we have done for 20 days, 3 to 4 times unscheduled downtime is required. Now the unscheduled downtime is limited to less than 1 time per month. The energy consumption is before it was 1000, now is 850 gigajoules. Maintenance cost is high before analytics, and after analytics it has been. So application of advanced data analytics in a chemical process will help you to find it out the most effective parameters which are responsible for the optimization, that also will help you to reduce the energy consumption as well as the maintenance cost. That's what I would like to highlight here. Okay, so coming to the learning outcomes. Okay, predictive analytics is superior to reactive maintenance, and learn how to combine domain knowledge with machine learning. Very, very important. Unless you have a domain knowledge, by knowing only the machine learning techniques will not help you. Sometimes we need to override the rules by using the domain knowledge, because in terms of the safety as well as in terms of the efficiency of the process. Okay, gain insights into time series modeling using long short-term memory for process behavior prediction. And we have discussed in the previous section very elaborately. Okay, these three questions very important. Why should we interpretable models or be preferred over deep learning? And the second question, how do you balance accuracy with the explainability? Okay, so this one, explainability will sometimes will overrule. Okay, the accuracy, even though the accuracy is more predominant. Okay, so because some of the regulatory agencies will look for explainability. Okay, so documentation purpose. Okay, or need to say to them. Okay, so explanatory is very important. And then the machine showing the thing, obviously we can take it, but at the same time we need to overrule the things by means of the human brain. That is very, very important. So this is how the accuracy versus explainability I can explain. Okay, the human brain versus the system. Okay, so that is a way I could would put it in a metaphor. Okay, so in safety critical process, what are the challenges in developing the machine learning models in live chemical plant? Okay, what are the challenges in deploying machine learning models in the live chemical plant, which we have discussed very elaborately. Okay, with this note I stop it here. I believe that this all discussion in the last class will help you. Okay, so coming to the last part, what are the challenges in deploying the machine learning models in live chemical plant? Deploying the machine learning models in operating chemical plants presents several technical and operational and human related challenges. Okay, data quality and availability. sensor drift, missing data, noise, and inconsistent sampling rates. Many plants have legacy systems with poor data logging. Labeling events like fouling, failure retrospectively is often inaccurate. Okay, so these are the things need to be keep in mind. Okay, coming to the cultural resistant trust, that is also very very important. Okay, engineers and operators may be skeptical of black box models. What is black box models? Okay, we never be, even though we are observe the input and output, we may not be knowing the mechanism behind how it works. Okay, so usually when I take maths answer, I used to say to the students, even though the system, okay, they can fully the full mechanism of how the different types of crystals which has been formed during the crystallization process is not fully understood, or else the delta L law is accurate for most of the cases, but some cases it may fails. They may not clearly explain why it has failed. Okay, there are some things. Okay, so where we need to think about all these aspects. Okay, so the black box is, even though we have a input and output data related, but the mechanism is not known. That is very very important. Requires training and involvement of plant personnel for adoption. Risk aversion. Operators prefer stable known system over new technology. Model generalizability. A model trained on one unit may not generalize to others due to equipment differences, feedstock variation, and environmental influences. So, the last time I told you the difference actually about the equipment differences. Okay, some equipment work on these different principles. Okay, even at the GCMS, gas chromatography, mass spectroscopy, even though that equipment is supplied by different suppliers. Okay, but the how the mechanism works, how the sample will try to identify the compounds. Maybe different equipment will predict the same accuracy, but the thing is that how this has been taken into account, what is the mechanism it follows to predict the composition of the compound, that is maybe different. Okay, so the obviously the procedure which you need to analyze the sample, okay, before you inject the sample to the equipment will also vary. Okay, so you should understand the equipment differences, feedstock variation, environmental influences. Okay, and coming to the another three subdivision is model maintenance, integration with the control system, and cyber security and compliance. So when you come to the model maintenance, models degrade over time due to changing condition, concept drift, needs ongoing monitoring, retaining validation, integration with the control system. Machine learning models must be compatible with the SCADA or DCS system. So the SCADA and DCS distributed control system, okay, have been connected with the system. Okay, by control room, they will try to find it out whether the process is going right or not. But machine learning models also must be compatible with this system. Otherwise, the system could not be able to understand the thing and try to give you a input. Okay, for example, model predictive control. Okay, so the model predictive control will not work properly, so that the variation will not be maintained, so that the accuracy could not be maintained. Obviously that will lead to the failure. Okay, so the requires API development, cyber security assurance. Okay, and compliance with the safety protocols. So integrate the cyber security assurance. Some should not actually come and interpret in the system and then change the data. So it's a safety aspect, because most, for example, just imagine a nuclear reactor. So now with the India-Pakistan war is going on in the last week, I think they were, even though they called for ceasefire, and there is a still there is some issues on the line of control. Okay, they'll say the people have been playing around with the cyber security. I mean, it's not properly maintained. So what will happen? The system could not be able to maintain. There are some few cases. The industrialization exposure happened because of the failure of the sensors. So the sensors are not properly maintained. The sensors are not showing any alarm. The level of the tank has been increased more than 50%, for example. Okay, so if it is 80%, 90%, they still shows only less than 50%. Obviously, the sense the control room DCS system failed. Obviously, that will lead to a disaster. So you might have seen actually the US disaster because of the control system failure. What are the things which has been happened? Okay, but not control failure in the sense the sensor is not been predicted, that is not been reflected back in the control room. Okay, so the cyber security action, just imagine the data which has been collected and going for the deep learning model system. If it is not properly accurately measured, or the people interpret the data, what will happen? So that may lead to the failure, giving alarm or accuracy, so that the failure may happen. So requires API development, integration with the control system, cyber security assurance. So it should not, it should be, it will be fully protected, and compliance with the safety protocols. Okay, safety protocols, we at any cost we should not come out with the I mean at no cost we should forfeit the safety. Okay, so that means we should not compromise for safety for any purpose. Okay, and coming to cyber security. So the another point is some cyber security and compliance, ensuring machine learning systems are secure, auditable, and compliant with industry. Okay, compliant with industry, not compliant. Okay, so compliant with industry standards like ISA 95 for automobile integration, ISC 61511 for functional safety. So, with this note, I just try to wind up this recap, especially what has been covered on the last part of the case study. Okay, so I don't want to go back behind it because we need to cover another one unit, unit 5. Most probably we'll try to complete by this week, Sunday. Okay, even though I've taken another one because today is the last working day for you and tomorrow the FAT exam starts. Okay, so I will try to project the material which has been under process of preparing. Okay, the unit 5 that I will share to you. Please try to concentrate on the unit 5 as well, is equally important. Try to recall back what has been covered from unit 1 until unit 4 right now. Okay, so don't wait until the last moment. Try to start preparing on your side from the, now onwards, so that you have another few things. So hopefully we will try to have a unit 3, 4, and 5, and the fifth unit half. Okay. So I think believe two we will have 3 units better, right? So 3, 4, and 5, because the first 2 units you have written in FAT 1, and all the other faculties and everyone is keeping another 3, 4, and 5 as a FAT 2. And I already shared the assignment as well. Okay, so please try to complete the assignment and return back to me, and try to complete the MCQ which has been embedded in the lecture. So these are the having a weightage. I need to give you marks to the COE office. Please try to complete the assignment and return back to me at the earliest. And also please concentrate now onwards. The unit 3 and unit 4 is fully completed, and unit 5 I'm working on it. Most probably I will try to complete by before Sunday at the worst case, or maybe tomorrow. Okay. So with this note, I stop it here. I believe that you understand what has been covered so far in the few lectures of unit 4, as well as the recap of this last two subdivision. Okay, so thank you for your time. We will see in next class with the unit 5. Thank you.